Hello everyone. So in this session, I'm going to explain about how the shift reduce parsing is done for the given grammar to parse the given input string. So for shift reduce parsing, so we all know that here only 4 actions are allowed. That is shift, reduce, accept and error. So to know whether a given input string is accept or error, we should follow the shift and reduce actions, and finally we can able to find out whether the given string with the suitable grammar with the given grammar is accepted or error. So for that we need as usual stack and input string and the action, parsing action. So in the stack, we are going to be having only the dollar at the initial state, and the input string, we are going to be writing the string which is given to us to parse and to find out whether it is accepted or error. So writing the string as A1 minus bracket A2 plus A3 at end of the input string, dollar should be must. So initially the stack is empty, so first action to be performed here is shift. Shift is nothing but the leftmost part of the input string should be shifted into the top of the stack. So now dollar should be there and A1 will be shifted into the top of the stack, and remaining string can be written as usual A2 plus A3 and dollar. So now in the given grammar, whether A1 can be shifted, A1 can be reduced with any of the production or not, I'm going to be checking. So A can be directly, so here we have A's at the 3 places, A. So for easy understanding, it has been given the numbering. So actually we don't have the A1, A2, A3 in the given grammar, only A we have. Just for understanding purpose, they have given the numbering in the input string. So if this A1, A2, A3 can be replaced with A only from the given grammar. So here if I check whether A is available in the given grammar to reduce, so if I'm going to be checking yes is directly derived A, so that here I can do the reduce operation, that is S is deriving A. So yes, A is reduced with yes, and as it isly I'm going to be writing the input string as usual. So now yes is not directly derived by any other production, so that I can do the shift. What I'm going to be shifting, what is available at the leftmost side of input string, that is the minus. So here I have shifted A1. For understanding purpose, I am writing which string we are going to be shifted into the top of the stack. So now dollar will be there. Yes is as usual like that only. And now what we have shifted? Minus is shifted. And what is available at the input string? Only A2 plus A3 and the dollar is available. Now checking A minus is available in the grammar. No, S minus is available in the grammar. So again I am going to be shifting. What I can shift here? Open brackets. So dollar S minus open bracket here. And what is remaining here? So A2 plus A3 closed bracket and dollar. So now I'm going to be checking S minus open bracket is available in the grammar. No. So that again shift action is done here. So shift of A2 is done here. So as usual S will be there, minus open bracket A2 will be available here. So which is remaining in the input string? Only plus A3 closed bracket dollar. So S minus open bracket A2, whether A2 is available here? Yes, A is available in the yes. So I can use the reduce A with its production, that is only this will be reduced. So dollar S minus open bracket, A can be derived from yes. So in the place of A, I'm going to be writing yes and writing the remaining input string as usual. So now again I'm going to be checking yes minus close bracket yes, or directly yes can be reduced by any its production. No production is available, so that I can do the shift operation. Now which one I have to shift? The plus has to shift, so that I'm considering the plus here. So next, so dollar yes minus open bracket yes will be like that. What just now I have shifted from the input string to the top of the stack is plus. So again this is not available in the grammar, so that I'm moving towards the next remaining input string. Here is A3 closed bracket dollar. Again I have to do the shift operation, that is the A3. So dollar as usual yes minus closed bracket open bracket yes plus A3 here, and the remaining string is closed bracket and dollar. Now check that yes minus open bracket yes plus A3 is available in the grammar. No, either A3 is available in the grammar, yes A is available in the grammar, so I can perform the reduce operation, that yes is A can be reduced with its production, that is yes. So dollar will be same yes minus yes plus yes. So now I'm going to be checking yes plus yes is yes plus yes can be derived from any of the yes plus s can be s plus s can be reduced by any of the production. Yes plus yes is available, so that again I can perform the reduce operation. So reduce yes plus yes. So yes plus yes will be reduced with its yes. So dollar yes minus open bracket, this s plus s will be reduced by using the first production here, will be reduced, and the remaining input string here is closed bracket and dollar. Now again checking directly yes is derived from any of the given production. No production is directly deriving yes, so that I can do the shift operation here. What else remaining in the input string? Closed bracket is remaining, so that same dollar yes minus open bracket yes, and what I have shifted, this closed bracket has been shifted towards the top of the stack. What else remaining in the input string? Nothing, only dollar will be available. Each and every string, each and every character in the string we have checked, and wherever necessary in that place we have done the shift operation, wherever needed we have done the reduce operation, so that now the input string in the input buffer only dollar is left over. And checking whether yes minus within the brackets yes is there, no complete input string is not produced by any grammar, and checking only this part, yes within the brackets is available in the grammar, yes production 3 is deriving that, so that I am doing the, or I am performing the reduction operation, that is yes is deriving yes within brackets. So yes minus this can be replaced with yes, here the dollar will be there. Checking yes minus yes is available, yes minus yes is available with the yes. So again performing the reduce operation, that is yes can be derived by replacing it yes minus yes. So dollar yes, so dollar yes, so here only dollar is there. So checking yes can be reduced with any other production. No, yes is directly cannot be derived from any its production, but we can check yes is the initial state and the top of the stack is only yes, and the input string it is available only the dollar, no input string is left over to parse. Now we can perform the action, or we can write the action as accept. So the given string with the help of the given grammar we can able to perform the shift reduce actions, and finally we have done an action called as the accept action. So this is how we have to parse the given input string with the help of the grammar. by applying the shift reduce parsing. So in the name itself we can understand clearly it can able to do shift and reduce operations, and finally it can able to find out whether the given string is accept or error. Suppose I will give the example like how error can be done. What about the error action? I have given the example that the string is accepted, so the action accept we have done. So what about the error? So I'll explain that. For the same grammar, we will consider the different input string. I'll explain about in which cases we will do the or will consider the error action. We have seen in this example we have seen shift action, reduce action and accept action. Then what about the error? In which cases a user will get the error? Suppose now the input string is a plus a into a. Suppose the input string is this one, right? So stack always starts with a dollar and the input string here is a plus a into a and ending with the dollar. So initially we have to do the shift action. Why? Because the stack is empty. We have to push, we have to start the reading of the input string from the left to right. So the a will be here. So shift a. So here dollar a and the remaining string is plus a into a dollar. So a can be directly derived from yes, right? So that I can do the reduce operation, that is yes is deriving a. So this a can be reduced with its production, that is yes. And remaining grammar I'm going to be writing plus a into a dollar. So yes is there. So again I have to perform the shift operation, so that a shift plus into the top of the stack. So dollar yes plus. So S plus is, I'm checking in the grammar whether any production is deriving S plus. No production is there, deriving only S plus. So that again only the input string available here is A into a dollar. So I can do the shift operation here, shifting A. So the dollar S plus A. What is remaining here? Into A is remaining here dollar. So now S plus A, I'm checking S plus A can able to replace with its production. No S plus A is available, so that I'm checking with the all possibilities. But here A can be replaced with its reduction by its production, so that I'm going to be performing the reduce, that is S derives A. So the dollar S plus will be as usual, and in the place of A is reduced with its production, that is yes, and remaining with the input string. Checking S plus S is available in the grammar. Yes, S plus S is available in the grammar, so that again I am performing the reduce operation, so that S derives S plus S. So here the S plus S will be, this is the substring which I identified, nothing but handle. This handle will be reduced by its production, that is yes. S plus S will be reduced with its production, that is yes. And what else remaining here? Into A is remaining and the dollar. Now I have to do the shift operation. What I have to shift? I have to shift the into. So yes will be like that only. I am going to be shifting the into. Right? And what else remaining in the input string? A is remaining and the dollar as usual. I am going to be checking whether only into is producing by any of the grammar. No. Or else yes into is deriving from any non-terminal. No. So that I can perform only the shift operation. So shift A. So dollar yes into as usual I am shifting A, and here in the input string only the dollar will be available. And what else I can do? I'm going to be checking yes into A is available. No, this input is this string is not available in any production. So that I'm checking all possibilities. The substring A can be replaced by its production, so that I'm choosing the handle as A and performing the reduction operation or reduction action like S derives A. So dollar S will be like this, into will be like this, A will be reducing with its production, that is yes, and here dollar only available in the input string. Now I'm going to be checking whether only S is deriving by the any grammar. No S is available in the grammar. Either S into S can be having anything, can be replaced or reduced with its non-terminal checking. S plus S is there, S minus S is there, S within brackets is there, but there is no production available in the grammar, that is S into S. So here I cannot able to perform the shift action. Why? Because nothing is there in the input string. There is nothing is there to shift anything from the input buffer towards the stack, so I cannot do the shift action. Next, reduction action. No production is going to be deriving this string. S into S is not available in the given grammar, so I cannot able to perform the reduce action also. To consider it as a accept, to make it as a accept, the stack should consist only the starting symbol. The starting symbol is yes, but here we have the two S's and one terminal, that is into in between these two S, so that we cannot consider this as the initial state and we cannot perform the action called accept. So in such cases, if the stack is consisting something, the production other than the starting symbol, and these cannot be reduced furtherly. Why? Because this grammar, the input string which we called it here S into S, cannot be reduced. Why? Because it is not available in the given grammar. In such cases, in such type of conditions, we can write the action here as error. Why? Because furtherly we cannot parse this by doing any shift reduce actions, so that we will consider here it as the error, and we can say the given input string A plus A into A is an error input string for the given grammar. We should not say this grammar is not accepted or rejected. For this grammar, we should say clearly that the given input string A plus A into A is the error. It has an error to the given grammar. So this is the situation or the condition where you can find out accept or error by using the shift reduce parsing. Thank you.